Hi everyone, welcome to Mr. Carlson's lab. Let's get the antenna portion of this radio receiver working again. Looks like these coils have possibly been heated by high power RF and melted the coil form or some form of a chemical. That has to be fixed because these aren't tunable because the slugs jam up in the coil form here. So L11, which you can see I've marked already, is fine. I can move the slug back and forth. L6 here, the slug binds up about halfway. You can see this has got a kind of a nice little turn on it. And then L4, which is the one that's right down on the bottom, is very bad. The slug is completely frozen in there. That's really melted. Just so happens that L4 is right at the top end of the broadcast band, so kind of interesting. So again, it's either chemical or high-powered RF, and we'll figure that out once we get the coil forms out of the receiver here. In order to do this, the first thing I need to do is draw this on a piece of paper. Snapping pictures is absolutely fine, but there's a bit of a catch to that. The wires are very fine, and there's a lot of crisscrossing wires in here, and unless you get many angles of pictures, as you go down coil to coil, you're going to probably end up with issues getting the wiring sorted out back onto the switch. So the best way to do that is to draw this out. You might be thinking, oh, that is going to be difficult. That's actually really quite simple. You just draw a straight line. So as this is going around, you just draw that on a piece of paper as a straight line. So this is what I mean here. So I'll zoom into this. So you can see on the band switch, it starts off at the top right by this rod. So this is our marker here. We have one tab on this side, one tab on that side, one tab on this side, and it kind of just staggers as it goes along. This one is a little different. It starts on this side, and then they're joined. Both sides are joined as it goes all the way around. So how do you draw that? Well, it's actually quite simple. I'll just knock out some of the light here so this doesn't overexpose. And that's all you do. So this is that rod. This is the rod right here. And you just draw it as a straight line right down. So this is right above the rod on the bottom portion of the switch, right down here, that metal rod that's opposite of this one. So we have one on this side, and then one on that side, and then one on that side, and just you draw them all the way down to this bottom portion here. Now, the reason I have 3 of them here is because as I remove each coil, I need to draw each coil's wiring out. So it's very hard to determine the wiring of this one because this is blocking everything. So I'll get this coil out and then I'll add this in. It's very important to note on the primary and the secondary which side of the coil goes to which tab, so don't get that confused. So you can see we have the bottom portion of the primary and the top portion of the primary. We have the bottom portion of the secondary and the top portion of the secondary. And as you can see, I've drawn that in here. You can see that. Bottom portion, top portion, bottom portion, top portion. So that's very easy to do. And as you go along, this is for L11. The next one will be for L6, which is this one, and the next one will be for L4, and it'll make reassembly very easy. Now on top of this, you can take pictures if you like, just for a little bit of extra assurance, but I'm telling you, don't rely on pictures alone when you do this, because these wires are fine and they're crisscrossing in there, and sometimes they'll come close to each other and bow out like this, and it looks like they're crisscrossing. And if you take that on a camera, a lot of the times you can't determine in the end which wires are actually going where, so you actually want to follow them very carefully, double and triple check before you remove these, because there's nothing worse than having to follow a schematic and relocate the tabs on a band switch. See what I mean? That is not very friendly to follow. You can follow it, it takes time, but this is much more friendly right here. All right, so what I'm going to do is I'm going to desolder these now and remove this. I just have to remove this nut here and desolder those wires, and then this one will come straight out, and we'll take a look at this one here with this nice bend. You can actually see the bend a little bit better right there. So I'll be right back. All right, so I'll take a look at this one here first, and as I can see, there's 2 little folds here, so I can take my very sharp wire clippers and just cut those off. Those are sometimes known as the wire ears. So just take that off like so. Now if I wanted to, I wouldn't even really need to use my desoldering tool to do this. I can just heat this and this wire will most likely come out. But when you desolder the area, it cleans out, leaves a hole, and it actually helps you point to the area where they were actually soldered before. If you leave solder on there, they kind of blend into the other ones. So it usually helps just to vacuum that out. So I'll get this on here first, like so. Move that. I might need to heat it to move this wire off. Let's see here. No, that actually worked very well, cutting those right off. So I've talked about that trick before, and that's basically all you do is you knock the little solder ear off just like that, and you've got your wire off just like that. So there's another little one right here. You can see there's a little fold right over here. So what I'll do is I'll get my sharp clippers in there, give that just a little bit of a trim. Now again, I could probably just heat this and pull the wire out. In fact, let's see if I can, how well this is going to work. Hopefully this comes around here. Iron's a little ways away. Should have had it a bit closer. And what I'll do is I'll carefully grab that. And let's see if there's any more. There might be more wraps, but I think this is okay. I'll heat this up. I can kind of see it trying to come loose there. Well, there may be more wraps around the other side. There it is. No problems. And lots of area for solder left. See that there? So I'll vacuum that one. Get this out of here, like so. Move this out of the way. Push that down so I don't burn that pipe. You can see that's basically come off and stuck on there. So that's the next one that's cleaned off, and I just worked my way around. So there isn't too many more here. Let's see, we've got this end over here, which is just a ground, and this one here. Maybe I can get this all in. So bear with me here. This one here looks a little bit more difficult. This is one of those capacitors that I've recently talked about. So I did a shorts on how to read these things. There's quite a bit of intricate information that needs to be known about these things, especially if you're going to try and replace them. So again, the end is purple here. So that purple means that this is N750, so negative 750 parts per million per degrees C. We have 2, and then 0, which is black, so it's 22 picofarad. And we can actually see the body's white, but they have a white blotch on this. And the white blotch means that this capacitor is 10% tolerance. So white on these capacitors means 10%. Normally silver does, and gold is 5% on resistors. Well, white means 10%. Now here's the catch with these capacitors, all right? So if this is under 10 picofarad, if the rating is under 10, which we know this is over, but if it was under 10 picofarad, that would mean that this is 1 picofarad positive or negative, all right, of its value up to 10 picofarad. So that's the tolerance. Over 10 picofarad, that means that this is 10% tolerance. So green is 0.5. All right, as I mentioned before, and that's in the shorts video. Green is 0.5 up to 10 picofarad, and then it's 5% after 10 pico. So I'll talk more about these in the video. These are very, very important to have correct, and for drift compensation. So when drift is moving one way, you want things to compensate the other to kind of keep it in the middle. All right, again, I'll talk a lot more about that in this video here, and I'll fill you in on how the capacitors and the circuitry works and why they choose these ceramic tubular capacitors, and give them that temperature coefficient rating. All right, so back to this. So this one here is a little bit more difficult. There's a big solder blob on there, and I don't know if they've wrapped something around there. So what I'll do is I'll just heat this one up, and I need to move this iron closer. Should have done that earlier. Let's see what's going on here. Add a bit of solder to this. Too much coffee this morning. Wow. Right, there we go. So that's hooked around here. All right, so it doesn't look like they've actually, I'm just going to steady my hand over here. Heat this up and see if I can bend that straight. I think they may have double wrapped that, or no, they haven't. Okay, so there it is. So I got to remember that these are also soldered on the ends here. So you got to be careful with the solder. You don't want to get them too hot. If you have too much dwell time with your soldering iron, dwell time means the amount of time that you have it on the joint as the solder is actually melted. So if you have too much dwell time, you can actually, melt this on the end here, and then of course you create an issue with the capacitor. So now that I've bent this straight, I should be able to heat this and pull this out relatively quick. And there it is, it's out of the way. So I'm not going to cause any issues to that capacitor. Now, this wire here, I'll heat this up again. Move this around, just heat this up. Let me see, this is wrapped around the top. This one looks like it's not wrapped too bad. You can see the end of it here. So I'll just bring this around like so. Hopefully that's not multiple wraps. It may be multiple wraps. I think it is a multiple wrap. I can kind of see something going on right there. Okay, so again, I can see the little ears here. So what I'm going to do is just get rid of them, because it's no point in sitting there and fighting that and then causing damage to the band switch or anything like that, especially with multiple wraps. So now this should just come straight out. There it is. There's enough to resolder there. If not, I can just retin it. And that area is out right there. Okay, notice I'm touching a hot solder joint. That's called years and years of doing this and no burns. I don't suggest you do that. I don't suggest you do that. Have you ever tried cleaning a soldering iron tip off with your finger? You probably, I don't suggest this either. You see, I don't know if you can see that there. You see that there? See that? I'll focus on that a little bit more. Let's see here. Give me a sec. There's the soldering iron tip. There you go, nice clean tip. I don't suggest any of you do that. Retin it there. But anyways, that's too many years of working with soldering irons and working around this stuff. You get to know your limits, I guess. All right. Mr. Carlson cleans the tip of his soldering iron with his finger. I've done crazier things. Okay, so now I need to get this off of here. This is the last connection. It's soldered to the chassis. Hopefully that is clear and in focus. Looks like it may be. Again, I'm doing all of this on a monitor here, so. There it is, that's off. That was actually pretty easy. Looked like somebody had just tacked that there. This one might overwrap. Let's see here. Definitely too much coffee this morning. Okay, so I'll put that in there. The further you get down and the closer you get to the chassis, the harder these are to move around. So let's see if I can get my finger in there. The harder that these things are here to get around. So reason being is the closer you get down this to the chassis here, so let's grab something to point to, or point with. So the closer you get down here to the chassis, the more that the chassis sinks the heat. So if you find that there's a blob that's on the chassis down here like this, what you're going to need to do is have a much hotter soldering iron. Again, you know, the further down you get, the worse it is. You've seen me use that big soldering iron of mine. And yeah, that's definitely important. All right, so now I need to get a wrench to open this up. I'll be right back. All right, look at those 3 beautiful coils right there. So this here will just fit on here like so, 9/16. Give this a bit of a twist. And there's the first coil. That's L11 right there. Hopefully that is clear again. Looking in the monitor here, yeah, somewhat clear. So that is L11. So now we can see the next one. Look at that. Now you can see the bottom coil. See what I'm talking about? Look at how bad that thing's melted. All right, give me a sec here. I'll move everything over and we'll take a closer look at that. All right, that's still a ways down in there, but you get the idea. Look at how melted that is. It's up here. Coil forms down here, top end's up here. So it's completely shifted. So anyways, I'll keep doing the same procedure with this coil, and I'll get this coil out as well. And once this is out, we'll take a look at them, and I'll get these replaced, and we'll move on. All right, all of the coils have been removed. So as you can see, this one here has got quite the bow to it, and the slug will get jammed in that nice little bend at the end of the coil here. And of course, the star of the show is the furthest one in. Look at this. So I looked at this under a microscope, and the slug is actually backed right to a piece of plastic, and the plastic is melted down to the slug. So this is from heat. So some form of RF has heated this. So whether RF got directly fed into the front end of this receiver, or this was really close to the transmitting station, maybe a harmonic or something got in here and melted that. That is just toast. So now what I'm going to do is remove the ones out of the CR-88 and replace these two. They're very, very close. The frequency range of the ones in the CR-88 is a touch different, but they're close enough that the two coils in there are fine. And for reference, here are the two coils out of the other receiver. Don't those look nice? Much nicer than the bent ones in this radio receiver, that's for sure. So I'll get these things put in, and we'll move on to the next step. The three coils are now reinstalled. You can see that nice new shiny one down in there. Well, at least new to this receiver anyways. And what's even better, get that to fit into there, into the index. Look at that, how nice and smooth that is. You can see the slug moving in the coil form there, and they're all like that. So they're all nice and smooth. So this section here is ready to be tuned. Get that into the index there. Yeah, no problems with that one either. So that's nice. So I said I'd talk a little bit more about these ceramic capacitors. So what I'll do is I'll zoom into this one here, and we'll talk about that one right there. Taking a look at this capacitor here, so we have purple, orange, black, and white. All right. Now you might be asking me, Paul, how do you know which end to actually start at? So what tells you that you don't start at this end and read this way? Well, two things. N750, all right, so the temperature coefficient is usually the first thing, and purple is N750. So that's a clue that this is the end that we start at. The second thing you can look at is the three colors in the center of the capacitor are the capacitor's value. And if you were to read it backwards, black, orange, that really doesn't make a whole lot of sense. But if you go orange, black, you get 33 picofarad. So right there, that tells you again that you're reading this way. All right, so again, N750, so negative 750 parts per million per degree C. We have orange, black, which is 33 picofarad. And then we have white at the end. Again, that's 10% tolerance. If we look at this capacitor over here, what's its value? You want to look at this here. So this is red, black, all right, in the center. So we see we have purple, red, black, and then white. If you want to guess at that, you can pause the video now and think about it. And I'll tell you what it is. So now, again, N750, purple here, or violet if you like. Red, black is 22 picofarad. And again, this is white, so we have 10% tolerance. Now, you might be asking again, why are these capacitors all over the place, and why are they using these ceramic tubular capacitors in these circuits? Well, in tube circuits, you have basically room temperature, and then when you turn the thing on, it gets incredibly hot in here. So you've got a really large temperature range that you're working with. So when you turn the thing on till it's actually up to temperature is its biggest, I guess you could say, movement time, when everything is drifting around. So by using capacitors like this, so these have a negative temperature coefficient. So some things in this radio receiver are going to drift one way with temperature, and some things in the radio receiver are going to drift the other way with temperature. And by putting capacitors in like this, they can compensate for drift. So while one thing is drifting this way, another thing is drifting the other way. Well, what happens with the drift? Here's a very easy way to understand what's going on between the components inside a radio receiver like this. So this is the frequency drift due to temperature change rubber band of science. How do you like that? So it's a rubber band that's just been cut and laid out. It's not stretched right now. It's just laid out and taped. And I put a line in the center here, and we'll call that center frequency. So we'll call the center frequency at 455 kilohertz. All right. So it could be anything. I'll just use this as an example. So positive drift would cause it to go to 465. And if we had negative drift, it would go from 455 down to 445, all right? So say we're at this point right now and the receiver is warming up, or it's pretty much warm, but it's in an environment where, say, the room temperature can change or something like that, because this is usually compensated to work the best when the radio is at operating temperature, okay? So to give you an example, so what's happening is we have some components inside the radio receiver. As the radio receiver is warming up, it's going to try and pull the frequency positive, all right? But the engineers at RCA, so say it's, we're at this temperature now, right? So the engineers at RCA are saying, okay, well, we need to put in some components that are going to drift in the opposite direction. Okay, so now we grab this end and we pull it this way. Well, what happens? Well, we end back up at the center again. And that's the tug of war that's going on between the components inside this radio receiver, and that's why there's so much engineering inside these things. Now, here's the trick. All right, this will help you recognize this. All right, let's take a look at the oscillator box. Okay, so here it is. Over here to the oscillator box, right about there. Get a little bit of light on the subject. I guess that's pretty good. All right. Now look inside this box, and what really do we have going on here? Well, we have mica capacitors and we have ceramic capacitors. Mica capacitors and ceramic capacitors. Well, why do you think that they're doing that inside there? Could it be because some components are moving one way and the other components are trying to even it out and pull it the other way? That right there is the sign of good engineering, right there. So this particular thing, this particular box, the oscillator box in here, took an incredible amount of time to engineer at RCA just for frequency stability alone. Movement in the chassis will cause frequency instability, temperature change, and expansion and contraction of just other parts other than capacitors. So in these days, they're experimenting with different types of plastics in the coil forms, different ways to tighten things up so that they don't move, placement of components and everything like that. So now you know why I changed the bypass capacitors in this thing, and I tested all of these micas and I left them alone. Well, the alignment is just around the corner. We're pretty much done on the bottom portion of the chassis. The only thing I can think of that we might need to address still would be this crystal here. A lot of the times the plates in the crystal oxidize and the crystal doesn't work properly. So we won't be able to verify this until we get into the IF alignment, and I'll show you how to do that. So I'll show you how to check the crystal frequency, and if the crystal isn't working right, we'll take it apart and I'll show you how to fix a crystal as well. All right, so now we're pretty much on to removing the face of the radio receiver so I can change that dial plastic. So let's get going on that. It's now time to remove the face of the radio receiver. So in order to do that, I need to remove all of these knobs. I need to loosen up these nuts here, so there's 4 of them on each side. I need to remove the headphone jack, and I also need to remove the audio control. Now these are some of the things that I can do from the bottom, so what I'm going to do is get that underway, and we'll take a look at the top side and see what we need to do there. Wow, that's actually very loose. And no, I didn't pre-loosen that. That definitely does not look factory. All right, well, it's loose in there anyways, not a big deal. And get that out of the way. Interesting. Maybe that's what they're using on the front of this thing. All right, so that's loose. Just leave that there. That's not a big deal. And each one of these has got to come off. That is... These are all very loose. You don't have to worry about marking this just because it has a stop. So these have stops on them. So if you forget, you just advance it to the far end and then align it to, you know, the last band. Not a big deal. Nice dust and debris seals. I wonder if they're very dusty. Not doing too bad. Not really much dust coming off those. These don't really look original or factory. You can see they're not cut very nice. So somebody has added these. So somewhere down the road somebody's worked on this, and that might be the reason that the standard nut and washer has been replaced with these horrible things. All right, I'll remove all the rest of the knobs. There's quite a few to go here, and we'll work at getting this thing off of the actual chassis itself. All right, all the knobs are removed. That only took a matter of moments to get all of those off. They're all relatively loose to begin with. So before I go turning this thing over, I want to remove these nuts right here. And they look like they would be 7/16. Definitely no metric stuff in here. Yes, they are. Okay, and now there's one on the bottom side down here. There's more that we're going to have to get to from the top side. There's one down there. So I'll just move you around here so you can see that a little better. All right. So that pretty much covers it from the bottom end. So I'll flip this thing over. We'll take a look at the top end, and there's more of these things that we're going to have to remove, and probably some other things as well. All right, the next step will be to remove this meter. It's attached to the face, and let's see what else is. It looks like that's about it. Actually, you know what? I can probably leave the meter on the face until I get the actual face off, and then I can remove the meter at that point, because there's some nuts way down in here that will be a real pain to get out. So you have to remove these three, 1, 2, and 3 here, and then the 3 on the other side. And I think we are in. So these things, they usually just pop out. There's a little meter lamp in there. There it is. All right, so there's the meter lamp. Just move that out of the way. And these look like they are, I would say 5/16. What do you think? It looks like about a 5/16, doesn't it? Let's move you in here a little bit more. All right, let me go see. Over here and go grab a 5/16. I think I have that screwdriver out somewhere. I do. Here it is. And does it fit? It does. It's 5/16. Or if you don't have 5/16, 8 millimeters usually works just fine. They're very close. All right, get that out of there. Now, the wiring. If you're unsure, you might want to mark the wiring if you're unsure. Get that out of the way. See that there. I did notice this meter in its travel when we were scanning through the bands that it did stick at some points, and then it would kind of loosen itself off. So we might need to actually take this meter apart and check out the movement. It might need to be loosened up just a little bit. I think this will be pretty straightforward. These wires are so stiff now that I don't think they're going to be going anywhere. So I know there's a line right up with the face of the radio. And then it's these things here. Let's just get rid of all of these. I should mention this nut down at the bottom here. You're going to need a universal and a 7/16" socket to get down to the bottom one there. And it's relatively easy to undo. I already busted it loose, but it's, there. Okay, the face is over the edge here, so it's a little bit lower than the lip, so there is no weight on this right now, and I haven't opened this one yet, or loosened it off, I should say. I'm hoping that this is all that is attached on this. You can see that it's already pretty loose now. And I'll remove this one. So I just left the two top ones on. I imagine this should, just by removing this, should make this a lot easier to move around because there's a fair amount of weight just in the faceplate of this thing. All right. There it is. Yes, there is a fair amount of weight in that. That's solid metal. That is solid steel. That is not aluminum. And that is heavy. No wonder these things are so heavy. The faceplate alone is, I don't know what that is, 10 pounds? I do have a scale. Just for the fun of it, I should put it on a scale. Let's see what that is. It's ridiculously heavy. I'm going to probably also remove these. And that'll allow me to clean the chassis just a little bit easier. Okay. Look at that. Dials are really nice. Got to be very careful with these. You definitely don't want to use any type of a chemical on this. I've seen this just wipe right off. People have wiped these off with chemicals. Now these are in very, very nice condition. So yeah, it'll just require a cleaning. Look at that. It's just so velvety smooth. Nice weight here. So that's nice. So once this is all cleaned out and has new grease on it, I'm sure that this will be very, very nice. That already is with this old grease, So now, okay, let's get rid of the sides. All right, so we'll go back to this side here. Those aren't tight at all. Well, not as tight as you'd think they would be. Yeah, you definitely think that those would be a bit tighter. Remove these. Boy, do those little felt pads sure make it easy to slide this thing around on there. So that is definitely worth going and buying a kit of those just to do this. Hey, look, a real life restoration. Where it actually takes time to get the thing apart and remove screws and things like that. Look at that, eh? There it is. Again, I can't even begin to listen to that. It's incredibly heavy, all these pieces. Once all this stuff is off, this thing will be a breeze to move around. So, put this over here. So now these things here would definitely be a desk killer. So when this thing is tipped up on its side or anything like that, these things would just gouge everything right up. So that's something that would have to be kept in mind. But sure makes cleaning the chassis easier. Can you imagine having to get down in there, but beside that wall and clean all this out? So it'll allow me to clean it up. Now I'm not going to go crazy with it, and just clean it up, get the dust and debris off of it, and probably use the same stuff that I normally use. And I'll decide on that, and if I do use it, I'll tell you what it is if you haven't watched my other restoration videos. So get this side off here. Will probably be much, much faster if I did use my DeWalt and just buzz these off. But by the time I go get my DeWalt and put it on this thing, I'll probably have this thing off anyways. this, this, and this. Just think, these things are put together by hand. No machines, nothing like that. Everything in this thing was assembled by hand. All the wiring on the bottom, all that stuff. Just think about the amount of people that were employed to put these things together. Would have been incredible. These things, there was a lot of these things put together. You know, the CR-88 version and, you know, all those. And there's the other one. Again, you know, it's just amazing the amount of strength. Imagine what this would cost nowadays to build. You know, this, and then of course to put this kind of quality behind something nowadays. You know, if you were to find this thing nowadays, it'd probably be made of plastic or something. Well, I doubt it. You can see how everything was put together in sections. You can see how this is screwed in up here. So this whole RF thing just fits in from the bottom and comes up to the top. So as you can see that it's layered here. So I'll zoom in. See how it's an actual panel that fits in here, and it just comes up from the bottom, and they put all the screws in all the way along. So, you know, pretty nicely built. Let's back out here a little bit more, so it's held in by this, this, and this. You know, and of course the entire cage underneath is held together by all these other screws that you see in here. Right, the same thing that you see on the bottom with a little stud sticking out. Anyways, now it'll be a lot easier to get in here and clean everything up. And yeah, I'm not sure if this is going to come off. Looks like a bit of surface rust, maybe. Well, maybe it will come off. So it might clean up okay. Yeah, probably will. So yeah, that'll be pretty good. So now what I need to do is I'll grab the faceplate again here, and I'll show you, you know, the plastic that I'm going to replace, and I'll tell you the procedure. I'm going to go get some color matched paint for that as well. I'll get that into the shot here and I'll be right back. All right, I just put the faceplate on a piece of foam. This actually came out of my toolkit, just so I don't scratch the bench up and of course make the face any worse than it already is. So getting this thing apart should be very, very easy. You can see it's just a bunch of screws. You can see how cracked that is on the backside. Isn't that horrible? And that'll sure look a lot nicer when, you know, have a nice clean one in there. Look at all the dust and debris on that, right? That's just from me cleaning it off. And of course, getting the meter off will be relatively easy. I have to remove it like this anyways, right? So I have to remove these. And by removing these, I can get rid of these nice little chrome bars on the front. Just put that there. And I can take it all apart, and that should, you know, pretty much make this thing, you know, almost flat. I might be able to remove this and take this off, and that'll really allow me to get in here and clean that up really well. And then once I have this cleaned up, I want it to, you know, be just about as nice as I can get it. And at that point, then I will take it down to just a local hardware store. And it's nothing special. All you do is you take it to their paint match counter. You can just get standard latex paint, and usually they have to, you know, I guess you could say tint up a relatively large tin. But it's not that incredibly expensive, and with that relatively large tin, they match this with a computer, and you take a little touch-up brush and put little, you know, the touch-up in these little areas here. You can't even see it; it just blends right into the face. And that's one thing that I've been doing for quite a while, and you know, it gets rid of this, you know, horrible-looking areas here. Now, mind you, this will probably be covered, right? But still, you know, any nicks or scratches like you see up here and all of that, that can be smoothed out, and then just put a bit of touch-up paint in there, and you wouldn't even know it's there. It's just standard latex paint, that's all. You know, and you figure out whether it's a, you know, gloss, a semi-gloss, or matte finish, depending on the, you know, whatever you have. And yeah, it's just, they're very, very easy to make look very nice again. So that's what I'll end up doing. And I'll end up sharing that with you once I get all of this done. So that's what I'm going to do now. I'm just going to take this plastic out and the meter off and get this thing all stripped down, clean it up, get some color matched paint, and get back into that, and I'm going to replace this plastic. So in the next video, you'll see all of this happening, and we're going to get into the alignment. So we're pretty much there. Also fill you in on how I cleaned the chassis and all of that stuff as well, so stay tuned. If you're enjoying my videos here at Mr. Carlson's Lab, you can let me know by giving me a big thumbs up and hang around. There'll be more videos like this coming in the near future. We'll be taking a look at modern electronic devices and antique electronic devices alike. So there'll be a lot of repairs and restorations, there'll be a lot of circuitry design, troubleshooting, even some teardown videos coming here. So if you're all about electronics, like I'm all about electronics, definitely subscribe and tap the bell symbol. That way you're notified as soon as I post a brand new video. If you're interested in taking your electronics knowledge to the next level and learning electronics in a very different and effective way and gaining access to many of my personal electronic inventions and designs, you're definitely going to want to check out my ongoing electronics course on Patreon. I'll share the link just below the video's description under the Show More tab. So if you click on the Show More tab, it'll expand the video's description, and I'll pin the link at the top of the comments section. So you click on the link, it'll take you right there. All right, until next time, take care. Bye for now.